Welcome, grade 10s. I would like to discuss in this short video series and parallel circuits. Now, to visualize the flow of current, electric current, in a circuit, you could use the flow of water in pipes. So, if you have your water will always flow from a reservoir that is high up on a installation or in the mountains like a dam, and the initial water comes out through a very wide pipe. So this is a high reservoir, so you've got high potential energy. As you need to supply different houses with water, the pipes that are used are forked. So there's a split in the pipes. So the current has more than one path to flow. If you use a narrower pipe, there would be a higher resistance to the flow of water. Right, if you add another narrow pipe, you add to the flow of the resistance of the water. But now I want us to go on to electric circuits. So by definition, a series circuit, there is only one path for charge to flow, and a parallel circuit, there is more than one path for charge to flow. Now charge would start off at a position of high potential energy, and like we discussed in class, we will discuss the flow of conventional current. Now, the apparatus that we use to measure the current flowing, the current strength in a circuit is an ammeter. Let's say we've got one resistor connected in series to that ammeter, and a second resistor connected in series to that resistor. There's a switch in the circuit that is closed, so we know that the current will flow, and the direction of the flow of current is, in this case, anti-clockwise. Now the current that flows into the ammeter here would flow out of the ammeter there, and it flows into the resistor R1. We'll name them R1 and R2. The current that flows into resistor R1 flows out of resistor R1. There is no leak in the circuit. So the current that flows out of R1 will flow into R2, and because there's no leak, the current will flow out of R2, flows through the switch and back to the battery. The ammeter in this case would read the total current flowing through the circuit as it is connected in series to the cell. The current through resistor R1 is the same as the total current, and it's the same as the total current as the current through resistor R2. So we have the situation where I total is equal to I1 is equal to I2. Let's look at the parallel circuit. In a parallel circuit, there is more than one path for the current to flow. So let's use our R1. Which is connected to a switch and to the battery, but here there is a split in the circuit and R2 is connected parallel to R1. So once again we consider conventional current, so the current flows counterclockwise. The ammeter is measuring the total current coming from the battery, so here we have the total current flowing through the ammeter. But at this point here, the current can split. Part of the current will flow through R1, we'll call that I1, and another part of the current will flow through R2, we'll call that I2. At the point where we get to this point, where the connector from R1 and the connector from R2 is connected, the two currents come together again. And the total current once again flows through the switch there and back into the battery. So in this case, the total current in the circuit measured by the ammeter is split. So I1, the current flowing through I1, the R1, will add to the current flowing through resistor 2 in order to get the total current. So parallel circuits are called current dividers. In the next video, I'm going to discuss what happens to the resistance in the circuit, and in the following video, I'll discuss what happens to the potential energy in the circuit. Thank you for watching.